go more. And okay, and then this is Ryan. Ryan is the operating manager of this factory company.
Of doing designing and fabrication is in order to provide a new product to satisfy the market need. That is why that we need all the parametric skills from computer. Besides that, we need to apply the skill into the real world. So that today I will do a briefing regarding to something that require the parametric skills and what you can see from a real project, which is linked back to the parametric skill that you will learn in your class. So outline will be the future possible development, the process of digital manufacture, and the panel forming. That we bring in some panel forming with 3D, and also some 2 or 3 case study. And since this is a briefing class, so I will go through very quickly, and you can ask me questions after we go through the briefing. Part of my study is called as Building Integrated Envelope System with Cloud 4.0 to integrate all the building envelope of a building and apply all the parametric skill from designing, fabrication, manufacturers, assembly, and installation on site, and apply those information into cloud. Is somewhat like a bin information in Revit, but more than that and more detailed. This is a basic picture in Mandarin. So when we do the designing, you do the system designing after you have done the structure and your shaping of the building. Then you go into detail of the system designing, and then you transfer all the digital data for manufacture, if you are able to provide the digital information for manufacture, and then go for a digital fabrication, piece by piece or panel by panel or element by element. And then you go to the next step for assembly. If it is a stick type envelope, that you ship the material to site. If it is a unitized system, that you ship the element into a assembly line, and after you assembly, then you ship the product. You ship the product to site for installation. So after you've done all that, you need to have a performance design during the designing stage, and then you need to have a performance testing pre-market, we say, before the project was installed. So there's a performance testing, and after system designing, fabrication, and assembly and erection, and then you got to have an accreditation of the performance on site after you complete the project. And if the envelope is controlling by a kinetic system, then you might need to have a logical CPU with the electrical system. So we call that, we might integrate all the envelope, become a smart facade to respond to the environment. So here are some briefing regarding the digital manufacture. When we do a curving panel, we can extract the information from Grasshopper and provide the data into the roll forming machine, which is a fabrication machine. And here is a video from a company named Zana, which is a German company but based in USA. They have adopted some of the digital programming and fabrication. So this is something that you are familiar, is a simulation of Grasshopper for a sheet panel. So it looks, you should be familiar to you, is the lab down in the basement in our school. We call that as a British roller. They use a robot arm to collect the metal sheet and go through a forward and backward process with a track to form the profile. So they also do experiment in their company. Same here in Gomo, we also do experiment. And you can see there are some rollers. They have different roller with different angle, different curvatures in order to achieve the different pattern and track to achieve the topology of the panel. So these are some possible shape by using the machine, which I call it as a British roller, to do the shaping. And for a panel, for a metal sheet like this, will be adapted on a building envelope, which you might see in some pictures or projects before. So this is the image to tell you what they do to clip the sheet in between the rollers and holding the sheet by the robot arm. Designing, which are something that you are going to produce from your class. So you see how the logic was designed, and the track line was designed from the surface topology by extracting the shape from rhino through grasshopper. Then you assume there is a path which can achieve the topology. So after you've done that, then you take a look what are the tracking path, what are the process that might be happening during your trial. So these are some logic: the shape, the track, verify, and the surface topology. So these are some samples they have done in their lab. I will provide you the PDF file, as long as you didn't tell them that we copied the content. Because this is already, you can already find from internet or something, or asking Mr. Google, so it's not a secret. And again, when you have a special building envelope with surface geometry like that, you will need to segment it and do the fabrication in the factory like that. So these are one of the nominal projects that you might see in the marketplace, but they are the process from fabrication to erection on site. So you, as a future architect or future envelope engineer, this is something that you need to learn, and which can also make you be more valuable. I mean, getting more paid. Panel forming. By adopting the digital tool and programming, you might be able to achieve those shaping through your programming and through the rolling, punching, and pressing, and perforated or expanded metal sheet with the punching, etc., into a different topology. And this is also something in the lab in the basement. You can see those panels hanging on the wall with the incremental methodology for achieving the topology. And this is a case study. Project is in Xi'an, China. You can play the video. So the whole project is with a certain pattern of facade and with a certain shape which could be programmed it with logic. And it makes the building looks like covered by a bamboo sheet. You might enlarge it. 音乐可以开大声一点。声音开大就可以了。So they also use some已经最大声了。现在我们要接一个喇叭。So take a look. This is shaping looks like the image of a bamboo, and this is the note of the bamboo. And actually these are all metal sheet. So they curve the metal sheet into a 3D geometry, and with what we call with the braking system, or you call it hooking system, to connect the panel to the main structure. So all the shaping is pre-designed in all the 3D programming, and you make it into a panel by panel sequence, and then you install it onto the wall. So we call this as a decorative facade because the system itself is providing the function of rain screen. It's not airtight and watertight, so we call it as a decor facade. This is a project by Hathaway, which is an old building of, we call it, I remember this is the factory for producing wine. And they use a 3D image to produce all the extrusion, curve it into different shape, and become a green room. So this is something that you can find from magazine. So this is another project by Carrie Jones, which is in university, Leeds University project with a spatial facade like this. As you can see, it's a car park in the university. So you can see that's the topology of the facade. It looks to you there is a certain sequence and logic from the surface, but it presents you a different topology from different angle. And this is the erection process, what they do, how they do it, with the mullion attached to the structure and with the panel attached to the mullion. So this embedding, breaking with the mullion and panel onto the mullion. This one is also a kinetic facade. We can play the video. They have designed a shape like a flower which are able to respond to music, and like the blossom flower, and before it was blossom. So you are not only to be an architect who doing all the shaping design, you might be involving some mechanism or electrical control. So again, this is a decorating system. So you can see they have installed lots of wiring on the wall before they put on this device. And see the reaction of each one of the flower. And this is also a design half a building from RMIT, which is a school. And they have a kinetic facade for sun shading. The facade appearance looks like this, but it can react to the climate. So we can play the video, so you can see how they move and respond to the climate. We go through the point of how they install. Yes. So they are doing the flooring before they install the facade. So later on you are going to see how they install the facade. See, the facade is installed panel by panel. It's pre-assembled and erected on site. We call it as unitized systems, even though it's a decorated screen. So see, that's one of the unit. One by one, the second unit. The third unit. And we go to the next video to see how they biometal. Not biometal. If I can produce a biometal, I become a billionaire. It's a titanium zinc laminate on galvanized. But if I didn't tell you, you couldn't see it's a bimetal. It looks like a one metal.
现在吗？现在吗？
可是要把它一定要让它再过来。
不是，因为你还要教他现在超高。
The cost is too high, and all the money was spent for the new machinery and invention. And actually, I don't have the ownership of the factory. We lease the factory, so I won't make it look too fancy. I won't put the lipstick on the panel. Many times in front newspaper, and the roofing is having the curvature in this way and waving in this way. So it requires a special methodology for erection on site. And right in front of you, there are two units of the roofing, which has a special curvature there are five curvature in one panel. So in order to achieve the accuracy and duplicate the same degree, we have also tried the robot arm in the school, and also we also developed a new mechanism in factory in order to duplicate the panel. Let's take a look at the unit. Come over here. During the designing, there were some physical criteria being requested by architect. The ceiling is required to achieve an acoustic value of 0.9 alpha, which meaning like 90% of the noise will be absorbed by this corrugated panel. And on top of this corrugated panel, there is a rock wool for insulation. So when you walk into this panel, you can get a feeling. Walk into this space, you are going to hear less sound reflection than outside of this panel. So the acoustic value, you are going to feel it obvious. And the perforation is the purpose for this function. And this opening is for skylight, which we can install onto it. And this lining is the butt joint between two units, which we haven't installed a flashing between these butt joints. This is all in order to show you the different panel. And the architect and controlling company has seen and confirmed the methodology already. There is those noise of designing and budgeting issues. And on the very top of this unit, there are some physical criteria, which is rain noise reduction. As you know, there is typhoon in Taiwan, so heavy rain like 200 millimeters per hour in an average of 10 minutes might happen during the typhoon season. So the rainfall is so severe, the noise created by the rainfall needs to be controlled. So an installation underneath the roof scheme needs to achieve 40 dB, which is something that a loudspeaker beside you singing the song and dancing on the floor, and on the other side of you, behind the wall, you will not be able to feel and hear the sound. But the trembling of the bed, you still will feel it, but much less. So this is something that you're going to see in the future. And take a look at on my left hand side, the steel structure right here. Actually, this is the gutter on the roof. And the direction of this panel, the total length of this unit is 247 meters. So this is going to run for 247 meters. You need my jewelry. So you know how big is the project. Normally in the discovery, we will call it as a mega project. And the gutter is going to be so high, totally my high. And you can come up with me to take a look what are the skills and what are the key points you need to pay attention. Put your hand on the rail and walk here. It's very safe on top of this rappel. On top of this tower. There are a framing on your right hand. This is going to produce roof shingle unit, like this. This is the framing, and we've got several layers, and on top of the layer is going to be the shingle, and which will be installed on this area. So the steel framing is in a, what I say, T shape. I forgot how to say T shape. It's not perfect rectangular, it's in this shape.
Tape.
Oh yeah.
A tape, yeah, it's a tape shape. It's a tape shape. So that is the tape shape framing, which is this one. And we are going to install the layers on top of the framing, make it unitized. So then we can deliver the whole unitized and install it to the roof in only 2 days. So you can see there are some layers and shingles. So for some of you, I heard that you were from Indonesia or some other country. So for those who are foreigners, raise up your hand. 1, 2, 3. Only 3. So shingle is more popular in your country. And for high-rise residential, precast concrete is also popular in your country. So you can learn more curtain walling and unified system in order to be more valuable. Okay, I think this is the, you see on your left hand side, far away in the factory, you can see there are several, one more bundle, second bundle of the roof panel. Actually, when we do the experiment of markup for D3, we have done several times of fabrication because we cannot achieve it at just one time. So there is no genius in this field. Practice makes perfect. Okay, let's go to the. Okay. Ryan is going to demonstrate the roll forming of manuscripts into the sheet channel for you.
继续走，往右手边继续走，继续走。老师，你看好线啊。
以后搞不好就是住着他们在发展这个。
All right, this is the cold roll steel roll warmer. Why we name it as cold roll? Because the strip, the metal strip, is a cold roll material, and the surface is alloy galvanized. So we call it galvanized steel. Strip, like a reason we call it cold roll steel strip. Roll forming in. Go through this roll forming machine, and you take a look at the roller. Each phase of the roller has a different shape. So it shapes the material through the rollers. Again, this is something that you can simulate from your computer program. So you are going to become a machinery designer as well if you learn it well of the program. Okay, Ryan. 我们要跑一片吗？
要。
Okay.
那我们准备开始哦。
Keep yourself away from the machine.
哦，这边小金同学啊，这边有料要动啊，我们远一点啊，两旁动一下，好。
好。
开始。
You can come over here, then you can see the result. It was formed into a sheet. That's the magic of the rolling. the guillotine. And for some Southeast Asian country, they are using light gauge steel frame. The light gauge steel about this size. So you use the G-channel like this because it's light gauge steel framing. In China, they call it prefab system. So it looks like it's a new term of prefab building. Actually, I was for 30 years already. Okay, let's move to the next factory. So you can see several roll forming machines in this factory. We have around 6 or 7 roll forming machines for different profiles. So follow me. Let's go to the small showroom in the second factory. 我们先看那个吧，先看那个吧。先看咱们家的这。Follow me to see the showroom first. So here is a small showroom, which is very small, but it contains most of the wall. You see, most of the products they could be used in most of the building. Right on your left-hand side, this is a sample of a unitized curtain wall, metal and glass curtain wall, and we can disassemble the whole unit. We can disassemble it. You see, I separated the unit already, and then I'm going to do operation on him to cut into another segment. So this is the logic of unitized curtain wall. This is the intersection of panel 1, panel 2, panel 3, panel 4. Oh, sorry, I named it wrong. Panel 1, panel 2, panel 3, panel 4. In a sequence. You should do the lower level first and then do the second level second. And this is an example of how the thickness could be for insulated glass. This is an example. It's not really like that thick. It's a 2-layer of glass with the air gap in between. So that we call it as air insulated glass, or you call it IGU. Alright, so on the left hand side, which is the metal unit, part of it. Alright, let's walk in. So you see some of the panel, which is for roofing or for walling, and this is a prototype that we have done for 3D pressing, to create a 3D geometry, like this. This is something that we practice in the factory. We adapt the image from computer, where we do a laminate strip as a backbone, and we laminate the finished skin over it. And take a bigger one on your right hand side. So I remember someone asked me just now, will we use those skills that we learned from computer into a real project? So now you got the answer. Will we use it or not? Yes, we will use it. It's a 3D curve with the laminar structure as the backbone. So then take a look of the small market like this, which is a composite roll form roofing system like a Taipei. This is the one that we use with different width between panel to panel. So you know all my secrets. And between the lower panel to the upper panel, we create a butt joint gap here with a membrane system and put on an extra strip to cover the panel. So the panel will look the same. And this rock wool is underneath of the skin to indicate that they are thermal, they will achieve the thermal requirement and fire writing standard. And this is the trench between panel 1 to panel 2. So you can see we have different width for this system and for that system. Okay, let's move to the next machine and let's go to come back to what the next product. We got on the left-hand side and one guillotine right over there and one press machine of high lift, which we can press the panel into different angles. So you can see when the sheet is extra long, they have a different way to produce the sheet with a shorter machine for a longer sheet. And this is double press bracket. This kind of work, this is what I've done when I was young. I operate the machine and do all the practice in the factory. So I know how to operate those machines quite well when I was young. And that's how I get my salary increase at the early days. And you see he's doing the QC checking. He's checking on the side and everywhere. And many of our workers are also from Vietnam. Some of them are from local workers, but some of them are from Vietnam. And the machine written with a LMT, which is a guillotine, which is to cut through the size of the small sheet. So when we require a special shape or special length, we can use the guillotine to cut into a special size. you can see they are doing the welding for special shapes. All right. Let's walk out from here to the headset. So those products in the showroom was produced, fabricated by using all the machines into this factory, in this factory. Take a look at the router machine. The product is going to be finished just about in a second. So now you can see the logo and also in the receipt. All the programs was written on our CPU. Okay, the one new controller. You can design the texture and do the lining or pressing, or you may name it drawing on the panel, and you go fabricate it. You create your own character of your facade. You may name it as your name. So this is all about what the digital programming can be achieved into a real product. So what's the purpose of digital programming? To produce a new product, right? And why do we need to produce a new product? Increase your value so you can get your higher pay in the future. Okay? All right, walk to the table on your left hand side and get your drinks and cookies. How the facade was reacting to the climate. So you can see it's a small drone with a circle disc, and the disc was controlled by a servo motor to control the angle of it. You might not hear what he is talking about. He's talking about all the digital projects. And if you're interested, you can Google the name of the project from YouTube, and you're going to see all of this. So the angle was controlled. That is倒退一点。here， 停在这里就好。So the angle was controlled by we call it a spin. They controlled by the servo motor, driven by the servo motor. So the angle of this spin could be adjusted. So it is rotated in this way, and all together in a vertical. We call that a vertical sequence, one by one. So this is another example of the kinetic facade. It looks like a flower, and this is the backing structure. It's like a what? The one. I don't know how to say that in English. You see an insect with looks like hundreds of legs.
Mini pet. Mini pet.
So we take a look at the second one, which is the image of LED you can screen your face and then the LED will be lighting on according to the image of your face. This one. Again, this is also part of the program of Grasshopper. You can screen your face image into the program, and then the decorative facade will react to the image. And what we normally use in a daily basis is somewhat like that. When we have a geometry like that in a facade, then we might adopt all the 3D skill that we learn in school to produce the panel, which is in a various size with a various angle. From structure, first layer, second layer to the skin layer. So when we do an architecture design, actually we design the envelope, the shaping of the envelope first, and then we design a structure to support the skin. That was the design process. So when you design a building, you decide what it should be looks like at the first stage. Second, then you select what are the material and the feeling that they want to present to the audience or to your client. So then the shaping is the first thing that you decided. Second is the material. And the third one is the cost. And the fourth one is the scheduling. So there's a certain sequence for when you do the design. And this is the project of Taipei Dome that we just completed last year. It was interrupted for around 2 years or 2 years and a half. This is something produced by our studio, in the gas studio. We have adapted the topology and analyzed it through Rhino and Grasshopper, and then produce the panel and twist the panel in a certain angle in order to match the form. So these are some process that we have used in the programming, which you might use it for other projects. But this is an example that where you are going to use your skill. So then we through the analysis, then we decide what is the panel length and what will be the intersection between panel to panel. And then we find the panel is not a principal curvature. In some panel, they might be within the 3D situation. So the length of this side and this edge and this edge might not be equal when the panel is actually installed outside. You need to twist the panel, and you find there is a certain edge which is longer than the other edge. So we install the framing, bottom layer and the intermediate framing, and top panel, and into a finished skin like that. Questions?
So how did you fix the problem you just mentioned? If on-site is not equal to your fabrication?
I'm lucky that you are not the developer. Because you might not satisfied with my answer. When we have two panels butt joined together,
Yes.
it will squeeze to each other. So we provide a gap between panel to panel. So then it is allowed that one edge might be longer than the other edge. So the intermediate space could absorb the difference of different age. That's the trick that I use. No magic.
So it's like extra gap you created for this. So you keep it in what range? Like 2 centimeter, 10 or
Normally it's between 2 centimeters.
2 centimeters.
Yeah.
Okay, so the water will seep in, right?
It's another challenge question again.
Sorry.
We have provided a gasket system in between.
Uh-huh.
They were 3 layers of gasket were
Yes.
installed. So there's a bottom layer. Actually, you're going to see the sample later on in the factory.
Okay.
We have a bottom layer before the panel was lapping out,
Okay.
a bottom gasket. And then after we put on the panel, we cut the gap between panel. And then the second gasket layer, we call it a membrane. Put it on top of the butt joint, and then a metal skin. Put it on, attach it, and screw down to the molding. So, am I providing the right answer to you?
So the water will collect on the edge of the dome, right?
Actually, it's a smooth surface. If you look at the surface in the distance, you won't find there's any trench,
Yeah.
because we have a cap to cover the trench, so it make it looks thoroughly flat.
Okay.
And this project was designed with a zip standing sink with a round, we call it a circle on the top, and then they modify into a double lock sink. But as you can see, the panel is so long. They have the panel run from the outer gutter into the inner gutter in one piece. So the panel become a taping in this way. So they create lots of wastage. So the construction cost was too high. And then I provide a suggestion to adopt a flat top system by using the same width of each panel and just turning the angle between the butt joint. So the wastage was reduced quite a lot, down to only maybe 5%. But the original design with the taping panel from outer gutter to the inner gutter might generate 30% of material wastage, which is pure titanium.
Sure.
That costs lots of money. So at the end, the architect and the developer accept my proposal to use this flat top panel. But we still go through the same performance experiment: wind lifting, watertight, airtight, etc. And this is not the first project which was adopted with the flat top methodology. This is the number 10 project. So actually it's not a new methodology, but we do have the patent for the methodology and the material. The titanium was made into a composite system, which is with the core.
太酷了。
我们这里有复合板吗？
Normally it was purely a metal skin,
防水毯。
but it was produced into a... So before we put on the cap, it looks like this. And we also simulate the appearance by putting the bending into underneath of the extrusion, or with the butt joint, or with the overlap into the profile. So it's all different possibilities. And you can see that's the location of markup that we have done before in the factory. In the earlier In the earlier days, we have a markup in the factory so people can walk on to the markup. And these are some appearance of the panel. You can go and touch it, get a feeling of it. It's embossed skin. And underneath of this, there is something underneath of it. There are different surface treatment, which can make the panel sheet look like a wool. So we call this grain painting. You got a grain on top of the surface, which we can achieve. Looks like a wood, but actually it's a metal. And you can see there are some samples that were produced through the CNC router machine with the red copper programming. And there are some samples that were produced before. And this one is something that I was talking about. In the early days, the T3 roof was designed with this profile. That's what you just saw, which is a strap panel. And this is a reinforced clip for wing lifting.
Including this one.
Yeah. We call it the wing bar, in order to achieve a very high wing load. And this bar can be used as the rail for fall protection. Not like this, it's another new connection here. But it could be used as a fall protection, the rail for fall protection. And this one, here is the secret of the roofing panel. Underneath of the composite panel, there is a rough wool and the bottom skin. Like what you saw in the PowerPoint file. And here is also another special unit in a rectangular, in a triangle rectangular shape. And this is a terracotta for facade, which acts as a rail screen. And here is also some laminate strip with a 3D geometry that we created in the factory. With the extended wire mesh at the base, we can pour the concrete over it and become the precast concrete. And this mesh could be the membrane reinforced material for the whole panel. So actually we are able to produce the 3D precast concrete by adopting the methodology. Okay, we can move out. So take a look at your right hand side from here. A sandwich.
中间是
复合材料
隔音用
啊，
隔音用
Like this.
都有，减轻重量，减少金属的用量，然后它对强度有帮助，隔热隔音
OK
都有，所以它是可以降低成本，因为
上交
钛很贵，
My
应该
first
是高分子
degree
材料，
was electronics. Second one
这
is
是他们
material
的产
science.
品。
And the third one to be on the way
直接
is
用到
architecture. Why? Actually, when you are doing designing of a
然
building,
后重量
you need
减
to learn
轻
all the different，
厚度
knowledge.
变厚。
So
又可以玩
who is the greatest artist in the world? Architect. That's the one that you're going to be. So I
然后它还
invented
压
the
花，
composite material around
压花的
20
话
years
就是
ago.
结构又
And
更有
then
效
I
率。
also adopt the the things that I learned when I was
所以
young,
这
like
个
in
就
your
没
age,
有再额外
doing
的加什
fabrication.
么新
So I
的。
invent a
你
new
们里
system
面
to
都一样，它怎
become
么
a
层有这么厚
composite
啊？
roll
整个屋
form.
顶有这么厚？
那只是最外面的。
这个只是最外面，
Actually,
它底
it's
下还有
very
一层。
important for every one of you to have a hands-on experience
然后中间什么隔音、隔
operating
热什么
something
那个通通
or
都要，那个都跑不掉。
producing something or fabricating
所以他们
something
通常
with your own
跟
hand.
最后面的完成面跟结构体中间大概有30公
Perfect
分。
if you only use the simulation from
对
computer.
那个都有。
You are going to forget what is going to be the real
他们也要
reaction
做那个
from
音响的
material.
测试。
We call it the material character. And we do
不然
something
下在里面就
like this through
他
invention
如果这样
as well with the simulation of robot in order to create a 3 curvature or 4 curvatures in one panel. By using robot arm, we also try to think of what are the other possibility of mass production with different curvature in one panel.
Is this done in NTUSD?
No, this is the one. After the simulation of the robot arm, actually we have another mechanism in factory.
Okay.
That's what I told Professor before. That actually we do have a methodology to go for mass production. And you can see it's a roll form curvature surface with a side reinforcing. Why? Because when we have 2 panels together, we are going to lock it with a clip, and the reinforcement on the vertical wall, we call that a vertical wall, is going to increase the strength and also increase the figure in wind lifting. So that's part of the process of fabrication into a new product. Remember what I said in the very beginning? When you do digital design, what are the purposes of doing digital design, doing digital fabrication? You're going to produce a new product with your new tool and new skill. Okay, anything else? Anything else from you, the future architect, or the future inventor?
我想请问，就是前面不是有那个机械手臂吗？
嗯，
那个机械手臂会用在之后的制造的那个流程的部分。
啊，这是个好问题。Yes, we love to use the robot arm to replace the labor-intensive process, to replace the labor inaccuracy. So if the panel was moving forward or backward by human, would you be able to control the path? Might not be possible, right? So again, under the kind of situation, using the robot arm, using the mechanism to control the path is more accuracy than the man. But when you do the trial, is a robot arm better than a human? What do you think? When you're doing the trial, is a robot arm better than a human? There is no answer for that. I don't even know that as well. Because when you try the robot to go through the path, you might find some inaccurate result. So then you adopt the way of the judgment of human to improve those weaknesses. And then you rewrite your program and adopt the robot arm to control it. Right? So actually, when you write a program, you also need to use your brain. There's nothing absolutely right or nothing absolutely wrong. Not like that. Actually, it's a mixture of programming and human judgment. The robot cannot judge unless it learns to become so smart, can judge everything. Then we lose our job, right? No, you still keep your job because you can write in different programs to control the robot. So the earlier page, next one, go to 13. These are the panels they produce in a small shape. Actually, in a real project, you are able to produce in a larger shape. Later on, when you are in a factory, you are going to see some markup panel. We adopt the same theory, but we do it manually to produce a 3D panel. If you ever seen some of the project in German, in Düsseldorf, I guess, beside the Rhine, River Rhine, there were some old warehouse being renovated with a special scheme, with a curvature facade. They are all done in the old-fashioned way, cassette by cassette and co-bending by man on the side. But now you can do it pre-bended and make it unitized for high-rise. There is one project by Frank Gehry in New York with a special shaping curvature apartment and with a 3D panel like that, but in a unitized curve wall. So it might be still hard for you to think of that, but in another 5 or 10 years time, you are going to tell me the same. It's no secret. It's a common knowledge. We can all do it. You're going to be better than me, because in my old days I don't have this tool. So that's the reason why I need to go back to school to learn this new skill. And I'm no good in writing program, but I'm able to judge whether the program should be modified or not. So that's my function. Anything else? If not, we can go to
One more question, sorry. Since the dorm's roof is all manufactured by human being, right? Is there any possible, you think, in the future that like you can design some robot, maybe even you don't need human work, you just give them the materials so they can fix one panel by themselves?
It's another wonderful question as well. Let's go to the
Because I once saw some people working on the roof. I think it's quite dangerous, especially on the edge point.
Actually, when we do the erection plan, we do have a mechanism with a tracking and a roller underneath the track, which is able to twist the track, and the roller would go along to the gutter. But at the end, we are not able to use that mechanism. You know why? It's too huge. Not slim enough. Not like you slim. I'm too strong for that. And when we install the panel on it, we found that we might need to have 2 or 3 tracking curved rail on the roof, and it costs too much. Second, we was told that we can install the roof at a lower level at around 12 meters high, pre-assembly. But at the end, the developer changed the methodology of erection. They lift the structure up to the around 100 meters high, and then they weld the structure. So all the erection plan changed. So there is always a surprise on the side. And we did ever thought about that. And especially when the labor cost is so high nowadays, it is worthwhile for all of you and me to think of any mechanism can replace the labor intensive portion on site. And those strategies should be able to generate more value than using a human being. That would be a good subject for pre-assembly system. Later on, you are going to see a T3 model, which is unitized roof, which will be able to be lifted, moving by by a machine. We do have the recording of video, but I'm not supposed to show you right now, unless someday we get a contract. Then you are going to see something different. Okay? So let's go to take a look at the factory. Oh.
老师是问一个小
哦，
就是
后来
他们这个建筑盖完的时候，跟我们在电脑现场的时候，如果到现场发现尺寸有些，因为可能浇灌或是会有一些误差，
to our studio to complete this.
还是这个control到非常已经很精准。
没有，理论上是结构
From
完
the
成之后你要
programming of grasshopper
哦
and
但是
insert the program into the CNC
因为你实际
machine.
测量过之后，事实上你设计要
So when you ask me whether the things to be done on the paper could be done in a real factory,
你必须要
you got the answer right here.
用那种你可以吸收误差的能力去解决。
老师，这个是我们工厂特别为我们排队制造的。
OK，Thank you。